Imagine you're 35,000 feet in the air. Outside, a storm is raging, thunder rumbling, lightning slashing across the sky. Then, with a blinding flash and a sound like a cannon shot, lightning strikes your plane. Your heart stops. But here's the thing, the plane doesn't. This happens more often than you think. The average commercial aircraft is struck by lightning roughly once a year. Yet, catastrophic accidents from lightning are extraordinarily rare. So, what's actually going on? Let's break it down. How the strike happens. First, let's clear up a misconception. Lightning doesn't just hit a plane from the outside. More often, the plane actually triggers the lightning itself. As an aircraft flies through charged storm clouds, it builds up an enormous electric field. The metal fuselage concentrates electrical charge at its sharpest points. The nose, the wingtips, the tail. That charge becomes so intense, it can actually initiate a lightning channel, bridging the gap between two storm clouds, or between a cloud and the ground, with the plane caught in the middle. The bolt enters at one sharp extremity, often a wingtip or the nose, races through the airframe, and exits at another point, often the tail. The whole thing lasts a fraction of a second. In that instant, you might see a blinding flash, hear a tremendous bang, and feel the plane shudder. Passengers often describe it as being hit by a freight train. Flight attendants have seen blue and white light fill the cabin. Sometimes there's a smell, like something burned. Why the plane survives. Here's where engineering saves the day. Modern aircraft are essentially giant Faraday cages. The term comes from physicist Michael Faraday, who discovered that electrical charges on a conductor distribute across its outer surface, leaving the interior completely unaffected. That's exactly what happens when lightning hits a plane. The bolt travels along the outer skin of the aircraft. The aluminum, or in newer planes, the layers of conductive mesh woven into composite carbon fiber, and exits without penetrating the interior. The passengers, the pilots, the avionics, they're sitting inside a shell that's routing billions of watts harmlessly around them. But it's not accidental. Aircraft designers have spent decades engineering this protection deliberately. Every part of the plane, fuel tanks, electronics, flight controls, is certified to survive lightning strikes. The fuel tanks are perhaps the most critical concern. A spark inside a fuel tank would be catastrophic. So engineers seal every joint, cap every rivet, and design vents that prevent any ignitable mixture from building up. The fuel system is treated as the most strike-sensitive part of the aircraft and tested to a brutal standard. Avionics, the flight computers and navigation systems, are shielded with metal enclosures and protected by surge suppressors. Wiring harnesses are wrapped in shielding, so sensitive systems never see the voltage spike. What pilots and crew do. When lightning strikes, the flight deck lights up, literally. Warning lights flicker, circuit breakers may trip, and systems may momentarily go offline. Pilots are trained for this. Standard procedure is to run through system checklists, confirm all critical systems are functioning, and notify air traffic control. In most cases, the crew will divert to the nearest airport for a full inspection. Not because the plane is in danger, but because rules require it. No aircraft flies after a lightning strike without a thorough check. Inspectors look for burn marks called exit points or entry points, small pits or scorched spots on the fuselage surface. They check antennas, sensors, and pitot tubes. In most cases, the plane is cleared within hours. So, the next time you're on a flight and the pilot announces you're heading into a storm, remember this. That aircraft has been struck before, probably more than once, and every time, it did exactly what it was designed to do. The lightning wins the flash. The engineering wins everything else. Aviation has come a long way since 1963, when lightning caused the last fatal U.S. commercial crash directly attributed to a strike, a fuel tank ignition that led to stricter design standards still used today. Modern aircraft aren't just flying despite lightning, they're flying through it every single day. The sky, it turns out, is a lot safer than it looks.